Having spoken about the product rule, now let's come down to the quotient rule. Let's try to figure out what exactly, how exactly the quotient rule that we keep on using is derived. So when we're talking about a quotient rule, when we were talking about product, we were talking about product of two functions of the same variable. Now we will talk about the quotient. So the ratio of the two functions u by v. So ux by vx, both these functions are functions of x. So what we need to find out is u by v dash, or the derivative of u by v with respect to x, the variable x. Okay, so which is the variable? X is the variable. Okay, x is the variable. So we will be looking at the change in u by v as x changes. Okay, the rate of change in u by v as x changes. So first of all, we need to find out what is the change in u by v. Now the u by v would change because of x. Okay, the change is the new u by b function at a new point minus the original, right? So it essentially will be u x plus delta x upon v x plus delta v minus the original ux by vx. Okay, now how do I deal with this kind of difference? How do I find out this kind of a difference? We can easily take up LCM, the least common multiple, and then try to figure out this difference. So making the denominator common. So the task is to make the denominator common. So we take the product, and to make the denominator common, what I will have to do is I will have to multiply this term with this and this term with this in the numerator. Okay, so that when I am segregating the fraction into two parts, I will get the original. Okay, so vx into u x plus delta x minus ux into v x plus delta x, and whole upon v, the common thing that we have taken, v x plus delta x into vx. Okay, now some sort of manipulation as we had done in product rule as well. Now the manipulation that we will be doing here essentially will be of this sort. Denominator remains the way it is. Denominator remains the way it is. What I am going to do is, what I would like to do is take out certain terms in common. For that I will have to introduce certain terms. Okay, for that I will have to introduce certain terms. So what I feel that what would be beneficial for us is introducing the product ux into vx. So we add and subtract ux into vx. Why? Because that will give me something fruitful, so that I'll be able to take out something common. I will be able to take out vx common, or I will be able to take out ux common. Let's see how. Let's try to figure out how. So in case from this numerator, in case I take out vx common, in case I combine this term and this term with a minus sign, what will I have? I can take out vx common, and I will have u x plus delta x minus ux. Okay, see, this is the big bracket, okay, and vx is common. Similarly, the denominator of course remains the same. This is only happening in the numerator, and I have already segregated the subtraction part. So in the next, what I am left with, next term that I am left with, let me just change the color. So this is the term I am left with, this is the term I am left with. Now here, can you see something peculiar? Yes, there is a ux in common, so I can take out ux in common. So with a minus sign I can take out ux in common, and this minus sign becomes plus, and this plus sign becomes minus. Okay, so vx plus delta x minus vx is something that I get in my big bracket out here. Okay, so denominator, as I said, will be the same. Now let me divide everything by delta x. Right now, till now, we have not introduced delta x into action. Now, to complete my difference quotient, I need to divide everything by delta x. So, let's just do that. So, taking delta x in the denominator. So, this is my numerator. This is my denominator. I am not touching my denominator at all. I am just working around my numerator. Okay. So, if I divide this whole fraction by delta x, I can just divide the numerator. It's one and the same thing, right? So, I just pick it up in the numerator and combine it with the bigger brackets. Just see, I am combining it with the bigger brackets. Okay. Why am I doing that? Because that helps me in some manner, because I am familiar with this difference. I am familiar with this difference, and when I divide it by the same thing that is differentiating them, that is delta x, then I get my difference quotient. Okay, I get my difference quotient for some other function. Okay, so as soon as I take the limit as delta x goes to 0, what will happen? As delta x goes to 0, as just like what we did in the product rule, as delta x goes to 0, this thing will be nothing else but u dash x, and this thing will be nothing but v dash x, right? So, as delta x goes to 0, this is nothing but du by dx, this is dv by dx, du by dx multiplied by vx minus dv by dx multiplied by ux upon, whole upon, now vx plus delta x will, of course, via continuity will turn into vx as delta x goes to 0. Okay, so this is nothing but vx and multiplied by vx, so you get v square. In short, we call it the quotient rule, and we portray it as the following: vu dash minus uv dash gives me my quotient rule. Some application of it we will be looking into the next lecture, next video, and also the chain rule.